Welcome. In this tutorial, I'm going to talk about one of the most fundamental part of C programming, that is pointers. Pointers are used to hold the address of some location in primary memory. Whenever we declare a variable, the variable gets allocated in the primary memory or RAM, and we can store the location of that variable in pointers. And using pointers, we can manipulate that location for our purpose. So for example, say we have this variable declared here in our program named var, and this var is going to be allocated somewhere in our RAM. So let us take this block diagram and try to understand this. Location or address is nothing but the byte number where the variable is allocated. The RAM can be considered as the array of bytes where the first byte is actually the 0th byte, and it goes on with the first, second, third, fourth, and so on. So this is the first byte of RAM. So the address of the first byte is 0 and the address of the second byte is going to be 1. So this variable var will be allocated somewhere in this RAM. So we can consider that, for sake of simplicity, that it is allocated here. That may be different, I'm just guessing. So let's consider that the variable var is allocated here at this location 57153, and it's 4 bytes because it's integer. So the next is going to be 7154 and 7155 and 7156. So these are the 4 bytes where the variable is there in the RAM. Starting byte number of the variable is going to be the address of the variable. So the variable var is going to have address this 7153. So if I say that what's the address of variable var, it's going to be 7153. Now there is an operator in C, unary one, the ampersand operator, that we call the address of operator, that can be used in order to get the location or the address of a particular variable during the execution time. So we can use this in order to get the exact location of the variable in runtime. So let's see that. So I'm just modifying this program and I'm printing the location of the variable var in the memory. So I can use that just by using the %p format specifier. That's the format specifier that we typically used for pointers or addresses. So I'm just writing ampersand var. Now this ampersand var is going to return the byte number or the address in hexadecimal, and that's going to be printed in hexadecimal format. %p is going to print it in hexadecimal format. So let's see what it is giving. Here we go. You can see that it's the address of the variable var in the primary memory, that is in hexadecimal format. This 0x indicates that it's hexadecimal. Okay, we can still print it in some unsigned integer format with warning from compiler, obviously. It's going to generate warning, but it will print the address in an unsigned integer format. Here it is. You can see the warning as well here. It's generating warning because the format specifies types unsigned long, but the argument has type integer star. Now that integer star is actually pointer type because it's the address, and address is pointers. So that's how we can get the address of a variable in the primary memory, by using the ampersand operator. Now we can store this address in a variable for our purpose. That's the important point. We can store this address for our purpose in a variable that we need to declare as a pointer. The address of a variable can be stored in a variable that is of pointer type. So if I want to store the address of some variable, then I need to declare a pointer. Now here I want to store the address of variable var, which is of type int. So I need to store the address in integer pointer. If I need to store the address of a floating point variable, then I need a float pointer. So since here I want to store the address of an integer, so I need to declare integer star p. Now this star indicates that the variable p is integer pointer. That means whatever we are going to store within p, that will be considered as the address of an integer. That's important. Now if I declare something like this, float star k, then whatever we store there in k will be considered as the address of a float variable in the memory. That's the byte number of a float variable in memory. Now if I declare a variable something like this double star D, then the system is going to understand that whatever kept in D is the address of a double variable. Now why there are different types of pointers? Because the size of the variables are different. If it is integer variable, it's going to take 4 bytes from the starting point, and if it is float variable, if it is double variable, that's going to take 8 bytes from the starting point. Always what we are doing in address, if we are considering address, we are storing the starting point. Now in order to get the value, we need to know what's the size of the variable. So integer pointer is actually holding address of integer, that's the starting address of integer. So since it is integer pointer, we understand that it's 4 bytes from this point. Now if it is float pointer, we understand that it's 4 bytes from this point. If it is double pointer, we understand that it's 8 bytes from this point. Okay, so much talking. Now we are declaring a variable integer pointer, and I can store the address of the variable here in P. Now what happens? The address of the variable is actually kept in the pointer P. So here is the variable var. Okay, let's consider that this is the variable var, and we have a content 5 here, and that's 4 bytes. The name of the variable is var, and just consider that this is the address. And what we did, we have another variable P here, that is the pointer variable, and we have copied the address of this variable var, that is this 7153 here in P. So P is assigned with the address of the variable var. So now we say that the pointer P is pointing to the variable var. Now using this pointer, we can still get the content of this variable. Let's see that. Now if I write this code, say I'm writing something like this here, star P equals to 10 or star P equals to 10. Okay, that's fine. That means we are dereferencing the address. Star P means the value at the address contained in P. Now the address contained in P is 7153. So the value at the address 7153, that is 5. Since P is integer pointer, the system is going to consider 4 bytes from here. 7153, it's going to take up the values from 4 bytes because P is integer pointer. So the address here kept in P will be considered as the address of integer. So it's going to take up 4 bytes from here, and that's 5 here. So this 4 byte will be assigned with 10. So it's going to be 10 now. So we can manipulate the location using the address if it is there in pointers. That's the magnificent side of pointers. Pointers can be used to manipulate a location, the content of a location, as we did here. So I can just go ahead and change or print the content as well. Let me just print it, so that I'm just printing the content of the variable var here. Instead of ampersand var, it should be var now, and it should be %d because we are just printing the content. And prior to this, it was actually 5, and we have changed that using the pointer. So I'm running this program. You see that it was 5 and then it was changed to 10 using the pointer. And we can just go ahead and do something like this. If I write something like this, star P equals to star P plus 1, then the content of variable var is going to be increased by 1. So star is the dereferencing operator that we can use to access the value at the address kept by the pointer. So that's the introduction to the pointer. In the next tutorial, we'll go ahead and learn something more about pointers. Thank you.